what if you're asked for the molar mass of a specific isotopes? Now, in your the periodic table that you'll typically have with you on your exams will not have that information. That's something you really need to look up from a more extensive compilation like webelements.com. So, for example, if you're asked for the molar mass of carbon-13, okay, you're not going to find that in a typical periodic table that you have access to on the test. So you have to look it up. And so you can go to a website like webelements.com, for example, and you'll find what it is. So you go to webelements.com, which I already have here. Click on carbon. Okay, scroll down. Somewhere there's a link to the isotopes. Okay, and you can see that carbon-13 has a mass of 13.0033548378. That's atomic mass units. Okay, so I already have that here for you. It's 13.0033588426 atomic mass units. That means the molar mass of carbon-13 is the same number, but the unit would be grams per mole. Okay, so it's not going to be a number that you might find in a typical periodic table. But most of the time, like I said, you're not really interested in that much precision, so you can say to 3 significant digits, so the nearest decimal is going to be 13.0 grams per mole. Okay, so the numerical value would be equal to the mass number. Carbon-13, 13 grams per mole. Okay, now if you really look at carbon in a periodic table that you typically see, you'll see carbon right here. It's 12.01. That's your atomic weight, remember? That's the average mass in atomic mass units of a naturally occurring collection of carbon atoms. Most of those carbon atoms are carbon-12. You can see that average is very close to 12. So there's some carbon-13, right? So in a the number that you see in the periodic table, that's the average mass in a naturally occurring sample. So when you're looking for, typically that's what you really need, because we're typically dealing with a naturally occurring sample anyway. So when we're talking about the molar mass of an element, we don't really specify which isotope we're dealing with. We're just assuming we have a naturally occurring sample. So these are the numbers that you would find in a typical periodic table that you'll have access to on an exam. So according to this, the molar mass of carbon is 12.01 grams per mole. Some periodic tables will give you more significant digits, but it's usually good enough to go to the second decimal place. Okay, so when we're doing any calculations with molar mass, let's just go to the 4 significant digits. So the second decimal place for most of the common ones that you'll encounter. Let's go with 4 significant digits. Now, what if you're asked for molar mass of ions? Well, remember that ions result when electrons are lost or gained, right? But you've also seen from previous lessons that the mass of the electron is like almost 2,000 times less than that of a proton. So the masses of the electrons hardly matter, so you can just ignore them. So what if I ask you, what's the molar mass of oxide? You might say, oops, oxygen's right there. What should I do with the -2? Ignore it. Okay, so molar mass of oxygen is the same thing as molar mass of oxide ions. It's going to be 16.00 grams per mole. So just ignore electrons when you're dealing with ions. Okay? What about molecules? What if I ask you, what's the molar mass of water? H2O. Just add up the masses of all the atoms in 1 mole of your molecule. So for example, let's say you want to know what's the mass of 1 mole of water. You say 1 mole of water H2O contains, it's got, according to the subscripts, 2 moles of H, right? So 2 times molar mass of hydrogen is 1.008, so 1.008 grams. It has 1 mole of oxygen. So when you write H2O, remember, if you don't write the subscript is implied to be 1. So it's got 1 mole of oxygen. So 1 times molar mass of oxygen is 16.00. Okay, go for 4 significant digits when we're doing calculations. Okay, so your H goes to 3 decimal places. Your oxygen goes to 2 decimal places. If you add all of this, you're going to get a total of 18.01 6 grams. And we're just going to do 4 sig fig, so we're just going to do 2 decimal places. So you can say 18.02. So you would say the molar mass of water is, okay, molar mass of H2O is 18.02 grams per mole. That means 1 mole of water is going to weigh 18.02 grams. Or if you want to be more precise, you don't want to use the word weigh, you say its mass is 18.02 grams. Okay. I like to use the word weigh to refer to mass because when you're determining the mass of something, you're actually weighing. The process of determining the mass is weighing. So some teachers are somewhat picky about that because there's a distinction between weight and mass. But when you're determining mass, you're actually process you're actually going through is weighing. Mass is not really a verb. Some teachers would like to use that as a verb.